Welcome everyone to the GenAI Africa podcast where we decode the future, spotlight African innovations, and amplify your voices that are shaping Africa's digital future. And today we are just dealing with some very important topic, and we are joined by a special guest, of course, and we are with Tulani, who's hosting this episode for you. If you are a student, whether maybe you are a teacher or you are a AI innovator, AI developer, this episode is definitely for you. Tulani and Gabriel, how are you?
We're good.
Really excited to be here and to speak all things GenAI.
Yeah. Actually, Gabriel, to just give some context in that, the Gen in the GAI podcast is for generational, not generative.
Nice.
It's just a play on words. But yeah, man, you're welcome. And we have your bio here, and I don't feel like you did justice to your bio. I'm not even going to read it out. I'll just let you introduce yourself.
Sweet man. Thanks, Tulani. So, my name is Gabriel Cassim. I'm a full stack web developer by profession, currently building startups. And I've been in the industry for over 7 years now, working both in the private and public sector, projects within those spaces. In short, man, I'm a self-taught coder who's very, very interested in web technologies in particular, the entire full stack spanning cloud as well as AI. Over the last, I would say, 2 to 3 years, I've been working quite closely with technologies like machine learning and generative AI, particularly from an open source standpoint, and of course building agents and integrating agents into workflows of various kinds. But in short, I'm a geek, very much a fan of code, a fan of hacking, maybe not so much lately, but still very much a techie, even though I've navigated more into the business space now. But it's given me a nice perspective on, where this AI stuff is going. And I'm super keen to chat about it.
Oh, cool, man. If you don't mind me, if I can go back a bit, you mentioned that you're full stack, and you just made a transition to more into the AI space. Like, tell me, how do you go about in doing that? Like, is there any specific thing that you need to do, or any specific language, or anything that someone could focus on just to make that transition?
Yeah, I mean, absolutely. So I think I'll answer that question in phases, starting with the first part, right, which is full stack. So the reason why I became a full stack developer in the first place is, I don't know about you, but as a front-end developer, there's only so much you can do before you need a back-end developer. And the same vice versa. So the reason I'm starting with that is, you might not necessarily know everything within the full stack. You'll likely have either stronger back-end or front-end skills, but it's good to have an overarching kind of understanding of the technology and have a full circle in that sense. Now, naturally, from front-end and back-end, you're going to do some cloud. So for me, after learning full stack web development, it only made sense to start learning technologies like Docker and containerization, cloud, Kubernetes, compute, and so on and so forth. The reason being is that's the natural next step, right? So you've got your app, you've got your servers, and then challenge now becomes more infrastructural. And then so that's the cloud part, right? And depending on how you manage your infrastructure, and depending on the type of project, infrastructure really becomes important because it has big cost implications and scale implications. So one little configuration tweak could either save you money or cost you more money,
100%.
or choke you at scale. So yeah, infrastructure, I would say, is a very important thing to learn as well. As a dev, no matter what role you play, front end, back end, infrastructure, cloud, whatever, you do need to know your kind of part within the mechanism. So to answer your question there, for devs kind of learning, starting out, don't spend too much time, in my opinion, if you want to become a full stack, don't spend too much time on front end or too much time on back end. Learn something, check the box, and then learn something new. And then obviously in some areas you might go a little bit deeper. For example, data structures and algorithms, you might spend a little bit more time there. Or if you want to be a CSS pro, you might spend a little bit more time there if you're more like arty or creative in that sense. And the same goes for cloud. Or eventually pick what you like, and you'll most likely study it a bit more in depth. And then the AI part. So AI has, we can start with machine learning, right? In the early days, that had some useful impact for various applications. Although machine learning is, I would say, the barrier to entry and the learning curve is somewhat steep. It is quite language agnostic, so but the dominant language there is going to be Python.
Yeah.
But you can use TensorFlow and JavaScript. There are many JavaScript libraries. We'll mention a few, but PyTorch for Python, TensorFlow for JavaScript, or Python. That tends to be the route people take. But general machine learning is, you need to know your math. Maybe not. You don't need to be like Einstein, so to speak.
Yeah.
But knowing basic, linear regression, basic algebra, essentially, which gets used in these machine learning algorithms. What's interesting about machine learning in comparison to GenAI is that it's a bit more low level. You're doing a lot more. You're tweaking a lot more parameters, and you kind of in the meat of it all. There's a lot you do need to know to get somewhere with what you're creating. Versus with generative AI, we can talk about pre-training, post-training, and all of that sort of stuff. But in general, people like devs, so to speak, building with generative AI, the barrier to entry is very low. And I dare say that the learning curve is also not so steep. It's just a handful of things you need to learn to really get the most out of these AI models. But that's obviously assuming that a model has been created. So, ChatGPT, Gemini, DeepSeek, whatever, and then you're using that. But if you go under the hood, the pre-training, post-training, I think that's where things get a bit more interesting, because that's kind of like an expanded version of machine learning. But that's where we introduce to transformers and so on and so forth. So, but yeah, that's a different world of its own. Happy to chat about it too, because it's very much open, and the value being created from knowing these technologies. If people can be aware of the value that can be created locally, especially, it's really important, because majority of these models are outside of Africa, outside of South Africa. So in some sense, all of the values is leaving the continent and the country. Even though there's nothing stopping us from building these models here, etc.
So you mentioned the barrier of entry in like the generative AI space is low relative to machine learning. So do you think, to your last point, that we should be focusing more on the math and starting like small with the machine learning so we can understand the models that actually go about in building like generative AI?
It's a tricky one. So, in my opinion, I don't think everyone's gonna when it comes to like. So the reason why I said devs in the beginning
Yeah.
is because devs will use like Copilot, Gemini Code Assist, or Cursor, whatever. So you're using AI to augment your work. You're working with AI to get things done faster, solve bugs quicker, that sort of thing. So in that sense, it's very much democratized in the fact that most devs will be using it for code generation, debugging, that sort of thing. However, the building of these models themselves, I don't think I don't think it's something everyone would be interested in, to be honest with you. However, if you are interested in it, I think it's probably like the most valuable skill you can learn today. And I say that just because Zuckerberg, tried to bribe a few AI scientists last month or last couple of months.
They're paying the employee that they're paying $100 million
Yeah,
per year, which is crazy. $100 million per year, Jesus.
Absolutely. I mean, so if you can read these papers and translate that into code, that's a very high, it's a high in demand area right now. And it's moving so fast, unfortunately, that, as you go about learning about this stuff, you do need to kind of be aware of these changes that are happening, because there could be jumps in your learning also.
Like I'm just thinking, like you just said that Mark Zuckerberg is willing to get like an employee for like a huge sum of money. And from an Africa context, do you see this happening? Like us investing in this type of technologies or investment that probably would yield back like in 10 years or so? I don't know. Whilst the pace of technology is not slowing down, do you think is it wise for us to look into that core and focus on the fundamentals and try to build our own models that we can probably outsource to the world, kind of like what DeepSeek did, and then rather than use the DeepSeek to actually make us better? Do you think what level do you think we should focus on? I don't know if I'm asking the question correctly. Yeah.
Great question, bro. I mean, I love these questions. I can unpack them so much. But I'll try and focus on key points. So on the first part, right? So in some sense, whoever owns the foundations, so this is very much a foundational kind of industrial revolution, right? In the same way that, if you bought stock in, Microsoft, Google, or Oracle, you essentially bought a piece of the internet. So to speak, is very foundational, or at least the elements of the underlying technology. So it's the same with this AI stuff, right? So in my personal opinion, it makes no sense that there's nothing stopping us from number one, building our own models. But I'll come back to that one. And I'm glad you mentioned DeepSeek. There's a very important note there on the open source nature of these models. But just from a compute standpoint, right? So I think it's Cassava Technologies by Strive. I'm going to butcher his surname, Masiu or something like that.
Oh, yeah, the guy from Zimbabwe.
He's like one of the ballers of the side.
Yeah.
So He's in on it.
Okay.
There's a handful of people in on it in the sense that they're building these data centers and preparing power infrastructure here locally. So if you look at like growth of data centers, that sort of thing, you will see like here in South Africa and within Africa, it's very much in its inception.
Yeah.
Versus Europe, US, etc. They like relatively saturated.
Yeah.
So my first point there will just be foundationally, because if we have data centers here, you have compute here, and ideally power you want to be renewable, then what happens is you don't pay such a high margin on tokens, right?
Oh yeah.
So, and tokens is maybe not the right word for it, but altogether the cost of running this intelligence essentially will go down, right? So if you had a solar powered garage, and 10 NVIDIA GPUs in there, A100s or whatever, enough to run, one of these models.
Yeah.
You're running it off solar, and you assume the GPUs have been paid for. Then essentially all of your inference will be free, right? So essentially, one of the things I'm predicting is like, cost token will continue going down. Maybe not immediately, but it will continue going down. And the reason for it is renewable energy on the one end, and then on the other end, just improvements in these transformer models. So you get better inference, quicker inference. There are ways to like reduce processing using techniques like a mixture of experts, which basically think of it this way, right? So instead of having a room full of experts, you basically call one expert in depending on the query.
Okay.
So that uses less processing within the model. So that's one technique.
Also, it's more
There are other
efficient.
techniques like, so it's more efficient because, each expert, they carry knowledge with them, and that knowledge is data, right? It needs to be stored somewhere, it needs to be transferred. So all of that processing, it's like, picture if each of these people are like videos, right? And they come with like gigs of videos worth of quote unquote memory or intelligence. And you need to, like in a short span of time, make use of that knowledge. So in short, mixture of experts is one technique that's made the models great these days. I think O1 and most of the models these days use it. And so I guess I'm just saying in terms of the techniques, these techniques are improving, and that's why these researchers are so desired because they can actually understand these things and end up building models using these learnings. And then quantization is another technique in mostly post-training or fine-tuning, whereby you'd basically think of it this way, right? So I'm sure you're familiar with like 64-bit, 32-bit on a high level. And it's basically like saying HD versus standard definition. So there are ways that can use quantization in these models to kind of decrease the bit size, so it speeds up processing. So those are like two kind of techniques that are a bit, that have been a little bit popular. So I guess that's why. So back to your question.
I just let you go there because I'm like, you should just go more in detail of this because that's what we want. You want the technical stuff. We want to understand all of this. So feel free, man. Just go ahead.
So in short, right? So to come back to the question. there's a useful diagram called the adoption cycle, like technology adoption cycle,
Okay.
where like in the beginning you have your early adopters, and then it's
Oh,
like this
okay.
graph where it's like a bell curve, I
Bell
think.
curve. Oh, okay, okay. I
So,
think, yeah.
sorry?
No. Carry on. Carry on.
Yeah. So one thing to note with this AI stuff is we're very much in the like the early stage. So even now, compared to 2 years ago, at least now you see a lot more people, doing fun things with ChatGPT and whatnot. It's a little bit more like people actually know about this thing. Um, versus 2 years ago, unless you worked in the tech space, yeah, you probably didn't know about it, and you definitely didn't care about it.
Yeah.
Now it's progressed, but it's still very much in the early stages, right? So in these stages, there are the guys like that Strive guy and Google and Amazon building data centers here. They can get in early, before the rising tide, essentially. And that's, I would say, if there's one thing I would kind of carry over as a message, would be think like the guys selling shovels during the gold rush.
Oh, yeah.
Think like play ideally on a lower level.
Yeah.
And there's guys playing on every level which we can speak to, but I would say the most important thing for us would be to play on the lower level, but not in a way that competes with the Claudes, the ChatGPTs, and the Geminis of this world.
Yeah. Yeah, I think there's a lot of space for that, because there's a lot of companies that want to run their models within their own countries, and they have to respect their own data sovereignty and all of that. I think if you own the infrastructure, at least you can give a promise for that. We know that Amazon owns the infrastructure for the data centers that they have here. We know that, but are they still keeping the data here? We can only just, from what they say, I'm guessing, correct me if I'm wrong, like they're not taking out the data from here and they're putting it somewhere or anything like that. They're just keeping it here. I think you'd feel more comfort if it's like an African that has that built the data center and says it's hosting it here. So yeah, to your point, like we really should starting and looking at like building shovels, because running these data centers is also no joke. Like the amount of electricity required, the cooling of the data centers, the design, the security. I mean, it's insane. It's insane, man. It's a very interesting take that you just brought in, which is looking at it from a lower level and not a more of an infrastructure level, and not just at the model.
So it's on a lower level. It's a combination of infrastructure and the model as well.
Okay.
So, in my opinion, this is not like I don't know if there's like fact on this, but
yeah, I mean, it's just it's an open conversation. So yeah.
So I would say the level above that would be your agents and workflows. Think like the N8Ns, custom agents, agent development, that sort of thing. And then I think at the top would be like, ChatGPT wrappers, so to speak.
Okay.
But the way you would define it is on that middle level with agents, you're using existing compute and existing model. You're giving it tools and memory, and basically you're making it task specific, whereas the model tends to be generalized and kind of task, like agnostic. You can talk to it about finance, you can talk to it about this, that. It's happy to chat. Versus agents, they become more task specific. So you would embed them within a certain role and give them tools to essentially autonomously get certain things done. And then you get at the very top layer. But before I come there, the middle layer tends to integrate quite well with, an app or server. So what makes agents great is, the structured output. You can take that object and then do normal logic and processing like you
okay.
would.
Like a
Like you would.
JSON, you get a JSON output, and then you can use what you want with that.
Absolutely. So that makes the AI brain work well with hard-coded code, so to speak. Versus the top layer is more like I say, ChatGPT wrappers, chatbots. They they might not necessarily have like tools. They might still be quite generalized also, but pretty much useless, to be honest.
yeah, I can see you leaning towards more on the agentic side of things, and I just
that's where it's going.
I just wanted to ask you more on that, because some of us don't even quite understand what agents do. We hear the buzzwords, right? What is an agent, and how is it any different from an LLM? Right? How do you
Absolutely. Okay, I'm gonna start with the LLM, right?
Yeah.
So an LLM, a large language model, it's basically just predicting the next token, right? And we're not referring to diffusion models, which is another rabbit hole we might not go into. But diffusion models are quite cool also. So what the LLM does is, within its brain, depending on an input, it comes up with a sequence of words that it is certain about. And that's how you're able to get responses from it, essentially. So it'll predict this sequence of words, and then that combination of the sequence, if it's like high confidence, it will give that as a response. So that's all it is, right?
So it's probability, would you say?
Yeah, essentially. So what makes it become ChatGPT, Gemini is what happens in the post-training phase, right? And I'm going to come to agents, right?
Yeah.
So what I just, like the process I just described now is mostly like pre-training. At the end of pre-training, you get your base model. And this base model is basically just a fancy autocomplete, right? So what you then do on this base model is you do some post-training techniques. So this is where reinforcement learning will come in, and they'll basically kind of brainwash this base model into giving responses that fits how, like, the personality they want it to have. Now that process requires, you need data in all these steps, right? But within this post-training phase, kind of data you're working with is more like bot and human interactions.
Yeah.
So it's taken its learnings from the first phase, and now you're using reinforcement learning to basically align its outputs to a way that feels more conversational, right? So reinforcement learning is one technique, and as things evolved, they used, there's various techniques. So there's reinforcement learning, there's RLHF, which is, I think, the more popular one since ChatGPT, which is reinforcement learning with human feedback. So that's now where, humans are actually kind of,
Okay.
Sorry?
They involved in the process. It's not just machines.
Absolutely. So it's not just the raw data set, so to speak. Humans are now involved in like you got it 100%. And then I won't go into this one, but there is also RLAIF. Reinforcement learning with AI feedback, which is a very dangerous topic.
Yeah.
But anyways, after you've done this post-training, that's when you'll now get, so to say, like a model that you can actually deploy in such a way that people can talk to it and find it useful. And then in that post-training phase, you could also give it, and I'm coming to agents now, but if you want your model to be compatible with thinking, for example, if you want it to like think first before giving a response, that will happen in that phase. If you want it to have tool calling ability, that will also happen in that phase. So the model you get at the end of this post training would be one with thinking and various tool calling abilities. So that's the LLM, right? And the reason why I start there is because depending on the agent you're building, you can't just use any LLM. You'll need, for example, an LLM that supports tool use, or maybe your agent needs to think. It needs to do a bit of thinking before giving responses. Then you need an LLM or a model that has thinking baked into it.
Yeah.
So yeah, deciding and choosing the right model is very much part of the job. So what is an agent? Fundamentally, right? So you have these components. We've got the LLM. Then an agent would be your LLM plus your tools. So tools can be a function. It could be a hard-coded function. It could be anything you can do with a function, right? So JavaScript, Python, whatever. So you can call an API, you can do processing, you could literally just do a console log. But tools in the context of generative AI is where you would tell this, like you would describe what the tool does. So I could have a tool that calls, the weather API, for example. So I'd give it a description and tell it that's, the purpose of this tool. And then when you pass it to your agent, or so to say, like when it's working in conjunction with the LLM, it's aware of that tool in its dealing with queries. So if it needs to call that tool, it can do so accordingly. But in short, a tool is a function, right? Anything that a normal function can do.
Okay.
You can. So it's the perfect gap also in terms of bridging that, the LLM to the system, so to speak. And then memory would be the third one. So LLM plus tools plus memory. So memory would be, various kinds. But to keep it simple, you can just think of it as like chat memory. So there are instances where you want to have, you don't want to have any context. So like there are instances where the back and forth between like the user and the agent is just direct, right? So you don't want them to remember the conversation. And then there are instances where you do need that context. Either the chat context or external context. Now, memory is a very slept on topic, I'll be honest with you.
Yeah.
It's probably the most important thing in GenAI. And it comes down to embeddings and vector stores.
Oh, yeah.
So these vector stores and embeddings, it's basically like AI databases, right? So in traditional databases, you'll have tables with columns and rows containing, text data, for example. But in the realm of generative AI, these vector stores are indexes with semantic meaning. So in short, what that means is instead of like in a single column in a traditional, or a single row in a traditional database, you would say this item with index 0 is, like if it's a list of fruits, for example, we'll say, okay, cool, it's a banana. It has the color of yellow. Now we refer to the columns, right? So the row is the first row. The name is banana, the color is yellow, etc. So within one row, you can have like many columns, many dimensions, so to speak, to describe that one thing, that one item.
Okay.
Now, what makes a vector store and vector database different is the semantic meaning would be embedded into the index. So for example, picture if 0 in that case, so if the banana item 0, instead of like, we just know 0 is banana, right?
Yeah.
We don't need to check column. We just embedded the value of, everything to do with banana into that index 0.
Yeah.
And we know 1 is maybe apple, 2
Okay.
is going to be pear. And because there's a limited number of fruits, each of them would have a unique index. So, sorry?
No, man. Just, listening.
Okay, sweet. So, in short, this vector stores these indexes, and it's aware, like it knows, okay, cool, this group of indexes is, cars, for example. This group of indexes is like fruit and veg, and it's kind of able to classify them.
Yeah.
So if you were to visualize it on like a 2D Cartesian plane, all of the data would be on that Cartesian plane, but there would be like clusters. So maybe like on the top left will be information related to, finance. Top right, information related to,
kind of like a K-nearest algorithm or something like that.
That's where those things now come in.
Yeah.
So the beauty of embedding, like having these embeddings, is you can apply these algorithms. So the approximate nearest neighbor algorithm is one used for search.
Okay.
Similarity search, to be specific.
Yeah.
So picture doing similarity search in traditional databases, right? You'd have to like manually search through this database, which is, I mean, the bigger the database gets, the more processing intensive it is, right? And the more fun it can be. Yeah, more slow the query will be, essentially.
Yeah.
Now with these indexes, because you can kind of put these indexes onto 2D or 3D like Cartesian planes, you can apply those algorithms. So that approximate nearest neighbor algorithm will take an input. So maybe to use our example, we'll take an input of, an image of a banana, for example.
Yeah.
So maybe not one, but we'll take like an input of either text or image, and then it's able to start. So it doesn't go like top down, left, right through that index. It goes directly to basically where that number is pointing. So the input would be embedded. So if we give it like a text input of, to use our fruits example, banana,
okay,
that would get embedded into a number that is similar to the embedded number on that vector store. So that's how you get that. Because those numbers will all be near each other.
Because they grouped together and they have a similar fruit, like you just mentioned.
Exactly. Yeah. Exactly. So that's how that approximate nearest neighbor works for similarity search.
Yeah, man, this just felt like an MIT lecture, yeah? It's insane, man. I wish we could dive deeper into this and talk about this. The way you just broke this down.
The last part, though.
Yeah.
Yeah, just to close off this agents part.
Yeah.
So the last thing to that equation, so you've got your LLM plus tools plus memory.
Yeah.
And the last thing is your prompt. Prompt design, I won't call it prompt engineering, but prompt design.
Why is that?
So there is a distinction.
Yeah.
I think the distinction really comes down to how much, like, if you're just altering the prompt text, then it's design. Versus altering other parameters, like, there are many other parameters, I can't even think of them on the spot, but there are other parameters that you can pass down to the model for safety. There's this one, temperature is one of them.
Okay.
If you're in the realm of fine tuning and that's involved, then you fall on the engineering side.
Okay.
So, anyways, the last thing for an agent would be your prompt. So there are different prompting techniques, right? So as they say, trash in, trash out.
Yeah.
So a lot of people will be like, this AI stuff doesn't work.
Yeah.
And when you see how they like prompting it, it comes as no surprise. So one of the biggest things, going into this AI stuff, being early in the adoption cycle, is learning how to prompt and getting good at that. So if you want to build agents, there's no way around, you have to be good at prompting. The first reason is so that the AI needs to, you need to give it a role, excuse me,
Yeah.
and instructions, and, there's like, the, within the prompt, is kind of like an IPO model. So you describe, as an input, you describe, for example, you are, a certain role, and you'd give it instructions as the processing step. So these instructions can be like, read the user's query. If the user wants to do this, you call this tool. If the user wants to do that, you call that tool. And then you'd have the output kind of where you describe what kind of output you want back from the agent. Because you can have that structured output. So sometimes that's the hardest part, right? Just managing structured output. So in there you describe, look, I want you to return an object with these key and value pairs, and that's where things get fun, because a little bit of hallucination there can make your agent useless.
Okay.
So, but for the most part, they've gotten quite good at structured output. So all of those things you'd put into your prompt, and the most important thing to put in your prompt would be security, right? At the hackathons, always talk about secure by design, secure software development lifecycle. And there's a thing called prompt injection, right? So basically that's when your agent, because of how you've prompted it to be relatively open, or even an LLM in its kind of base form, is vulnerable to prompt injection, right? That's how people have got certain LLMs to leak information, because there's no instruction within the prompt to tell it what not to do. So, and also prompt injection can have token costs. So if you have an AI that is supposed to respond in, maximum like 2 sentences, and I come there and I tell it to respond using Shakespearean, plays, and now you're paying for 10 pages worth of tokens. Those are some security threats, but the term is prompt injection. And how you get around prompt injection is using a prompting technique called DARE, which stands for appropriate response. Basically, within the prompt, you would tell this thing like, okay, cool, now that you know your role, now that you know your instructions, just make sure that as you respond, you determine what is the appropriate response based on this. Otherwise, it still remains quite open-ended. So, and then basically you would tell it, if the user is asking for anything outside of the agent's scope, then you'll just tell it to respond with a certain message like, hey, I'm not built to do this. Unfortunately, I'm only supposed to do, I'm supposed to just tell you the weather. I'm not supposed to, generate Shakespearean poems.
Oh, okay. So they more, they protect you. The DARE method would kind of like protect you from invasive. I don't know if this is the right way of explaining it. Invasive prompts. That would just try to push your agent into doing things that it is not supposed to do.
Absolutely.
So you should like what
absolutely.
You say. Yeah. Okay. Cool. Another thing I just wanted to just ask you, how is because I've also kind of played with agents, but just not that much though, and I came across a scenario where I felt like I think an asynchronous function would have worked there. do you ever think about that when you're building? You always like just go in and like a client comes and says, "I just want agents." How do you go about in saying, "Okay, you don't need an agent here. Actually, we can just have like just a normal function for this."
That's probably the most important thing worth talking about. Okay, maybe not the most, but
Yeah.
one of the first, like while upskilling myself, I'll never forget, there was this, I was on a call with one of the guys from Google. His name is Zach Kill. He does a lot of the demos for the events where they'll have like demos that use AI, like you'll have like a soccer tournament AI sort of thing, or like goal kicking AI.
Yeah.
But anyways, one of the most important things is like they had a framework which basically was like what not to use AI for. Now, off the top of my head, I can't think of it, but I think a simple example would be like, a calculator agent,
Yeah.
like just use a calculator.
Yeah. Yeah.
So it's very much one of those things where people want to drizzle the AI sauce on everything.
Yeah. Yeah.
So absolutely, to your point, there's a bunch of stuff that should not, it should not be. But I think my word of advice would be from an interface standpoint, right? If you feel the nature of how you interact with clients, users, from a system standpoint, if you feel the existing interface is like, you get some people, was using some software that it looks like Windows XP. You get some apps that are useful, but, using your thumbs all the time, it just takes too long, or it's just too tedious. Hypothetically, like if I'm on Uber, like if I'm standing at the corner, why can't I just speak to something and say, look, call me an Uber to where I'm going? Why do I have to like unlock my phone and then remember why I unlock my phone and then click on Uber?
Yeah.
So,
It's a lot.
so for me, one of the things that's standing out is this natural language interface and how very soon, maybe not like the next 2 to 3 years, but possibly within the next 10, we'll stop using our phones. We'll probably have some kind of a device that still bridges the gap when necessary, but we'll stop using like phones, keyboards, for general things. Maybe like if you code and stuff, you'll still forever use your laptop and your keyboard and whatnot. But
completely hands-free.
I do for sure see. So to answer your question, right? For me, the biggest use of AI is one where if you want to reach your customers a lot of people are doing things over WhatsApp now, thanks to AI. But yeah, very much this natural language interface. It's a lot simpler and then it's also more accessible, right? Then, a lot of people can't use smartphones, but they can speak their home language, for example, or, some can't even afford, certain smartphones, but, in the near future, you'll have like really cheap natural language based devices that would bridge these gaps. And I think that's where this AI stuff is going. So if you feel your app's interface there's too many buttons, too many pages, consider, a one-page kind of ChatGPT type conversational interface, but then behind the scenes, it's still calling the same RESTful APIs that your app would call.
Cool.
It's just the agent did it for you.
Cool, man. I was actually of an idea. I think of an idea like that, but for just a small project on the side. Maybe I should rope you in on that, just as an advice on maybe what I should use some things for or what to not use. If you do have like some articles to share with us, I'd really appreciate that. You seem like someone. In fact, you don't even seem. You are someone with a wealth of knowledge in this space. We really appreciate anything that you share on our side, so we can just share with anyone who's listening on this or anyone who's within our space, because we really are trying to take AI to Africa. We're just trying to bring that knowledge base, and you're trying to bring it with with people like you who are involved in Africa and are trying to make this space more vibrant, especially to the youth. I mean, like there's a lot to do. A lot of people see barriers when it comes to AI, and they see that it's taking their jobs. But what about the other side? What about when you learn AI? What about the things that it brings? I mean, this is like the entire point of this podcast. It just give people that insight, and especially say, okay, Africa, we here to actually figure this out. And with people like you, I think Africa's hands is in safe hands, man. So, Gabriel, hats off to you, brother. The amazing work that you're doing. We didn't even get to that part. It's just the passion that goes to you speaking. I just decided to just like hands off, just let you speak, man. It's amazing. It's amazing. I'm inspired, and I think Bungile and the rest of the listeners listening here are also inspired by what you're doing, and the knowledge and this passion that you have with like the space of technology as a whole. Because I feel like you're not if something comes that might interest you, you'll definitely go towards that direction. Because I remember the last time we had a brief conversation, we met actually, was at a hackathon, and we were doing a hackathon with regards to like what's that, like IoT devices, and you were there. So it's like crazy,
Yeah.
man. It's beautiful to watch. Like you don't conform. Just keep at it, man. I love it, man. Thanks, but appreciate the time and everything.
Oh, I appreciate it, Tulani.
Yeah, appreciate it.
Awesome, man. Thank you.
Yeah. So do you have any question or anything you say before we close this off? Because just trying to wrap it off before we run out of time. Is there anything that you'd like to say?
Yeah, man. Yeah, definitely. Just thank you and good job on spreading the word. This is precisely what you need in the early phase of the adoption cycle. More people talking about it. Exposing. I tried to touch on some key points. There's a lot more to unpack, but I think got the key points out. And yeah, man, I think if people can just continue doing research on it. Hugging Face Transformers, I'll just stop at that. If you're really, really keen on learning and being in it, learn and upskill on Hugging Face Transformers.
Cool, man. Appreciate that. Bungi, anything on your side?
Thank you so much. I feel like time didn't do justice.
Yeah.
I just wish we can have like 3 hours, because you have learned a lot. I don't want to lie. I like the fact that you also touch on the importance of digital infrastructure, because we can't speak about AI without data centers and also computing power. So I feel like we just need to invite you again to speak around the AI tools, because people don't realize the potential of AI tools like ChatGPT. They think that you need to be at school for you to actually use ChatGPT. So I think we just need you all as another episode.
Not a problem.
Definitely.
Yeah, definitely go down the rabbit hole.
Yeah, man. Thanks, man. Appreciate it, bro. And
Awesome.
to everyone
Thanks, guys.
listening, thank you. Keep exploring, keep searching, and stay curious. Thanks. And that's a wrap.
Thank you.